Welcome everybody to the first Bronkhorst podcast series. I'm James Walton, and as you might have seen, we're going to run a series of podcasts to talk about the major trends and innovations in trace elemental analysis. I'm extremely excited to run this podcast, and I hope you will find the podcast interesting as well. As always, if you have questions, you can contact me directly on LinkedIn or via our website at www.bronkhorst.co.uk. We all know that trace elemental is important. Think about the water you drink. There are many toxic materials such as mercury that need to be monitored and controlled to keep us and the environment safe. So today I would like to share our knowledge and expertise in the trace elemental analysis market. I will be doing that together with our guest Rob. First of all, a warm welcome to you, Rob, and thank you for joining us today. It's a pleasure to have you here, and as our resident expert of this market, you have worked as both an engineer and product specialist in this market. That's why I would like to talk to you about the main trends and developments in the trace elemental analysis market.
Thank you very much, James, for the opportunity to speak about trace elemental analysis and the benefits of using Bronkhorst MFCs in the elemental analyzers. So to introduce myself, after studying analytical environmental chemistry, I worked a lot with trace elemental analysis as a service and sales engineer, as you said, before I came to Bronkhorst, that is, and that is now 11 years ago already.
Wow.
So at Bronkhorst, I now work at the global key account department, where we support globally operating OEMs, and that is including various analytical customers.
Fantastic, very interesting. So an easy one to start. Rob, can you explain to our listeners what trace elemental analysis is and why it is so important? When and why do trace elements need to be measured?
That's an easy one, you say, but some of the listeners, they will know that trace elemental analysis is a very broad description of a lot of different analytical techniques. So the common denominator, however, is that these techniques determine traces of elements that have an influence on our environment or are in another way important to processes applied in our world. So do you remember the periodic table by Mendeleev?
I do, yes.
You see all these elements in that table, and actually with trace elemental analysis, you can determine all those elements. And the focus lies a little bit on the heavy metals, like mercury, and actually mercury is a good example. Environmental applications of trace elemental analysis are the most appealing applications to many of us. Measuring the amount of mercury in drinking water, in fish, in soil is very important for our health and for the health of the environment in general. Actually, mercury, like I said, is a good example to explain trace elemental analysis a bit further. So,
okay.
James, I'm sure that you all also remember the thermometer when you were ill as a kid, and sometimes it dropped on the bathroom floor occasionally, or maybe on purpose it dropped on the floor. As a kid,
and
I
you
remember.
Can see the mercury spill out.
Yeah, I found it very interesting. So these small drops of mercury in its elemental liquid form, but mercury can have many forms, not only liquid, gas, and solid, but can also have a speciation is what they call in this field.
Okay, could you expand on that, please?
Yeah. So besides the elemental form, we know from the thermometer, you can have organic forms like methylmercury. And methylmercury can, after emission to the air by industrial chemistry, and then deposition to water and soil, methylmercury can accumulate in fish, in the tissue of fish, and can cause diseases. If people want to look it up further, you can search for Minamata disease in Japan.
And this is what we hear about on the news, is the buildup of mercury in sea life.
Yes, yeah. So because we eat the fish, of course, and then you get it inside your system. So this Minamata disease was one of the first diseases that came from environmental poisoning.
Yeah.
So besides environmental applications, there is also trace elemental analysis to determine the calorific value of food and other energy sources like wood, and to determine traces of contamination in semiconductor. And coming up are medical and pharmaceutical applications to measure working ingredients of medicines. So
So
a
there
lot of
really is
the,
a broad spectrum here.
yeah, it's huge, but you
Yeah.
can distinguish some techniques, and we try to do that, of course, to understand the market. There are a lot of different applications, a lot of different sample matrices, and a lot of different analyzers. What we did is we distinguished trace elemental analysis techniques in CHNS, which is also called microanalysis, atomic absorption spectrometry, and inductively coupled plasma techniques. The last one, ICP, together with a mass spectrometer, you can determine the speciation of the element. So you can see in what form is it in the environment.
So not only the volume, but also the form. So it
Yes,
allows you to get a real indication.
and if it's bound to like methyl groups or other groups, so that you can see, hey, where did it come from?
Fantastic. That's very interesting.
Yeah.
So moving on from that, can you share the new trends and developments in the trace elemental analysis, or I'll refer to it as TEA market from now on?
Yeah.
Could you talk to us about the way this industry has developed? I'm sure that the instruments from the 90s are not too similar to the ones we use now.
Yeah, that is correct. But you would be surprised, James, that the basic chemistry of these elemental analysis hasn't really changed since the 50s, and maybe even sooner, when atomic absorption spectrometry was introduced. ICP was commercially available in the 70s, and looking at the change in color of a flame by adding metals, that's something that the ancient Greek already did in their time. And who doesn't love fireworks?
Yeah, exactly. But I'm sure that our instruments are a little more complex than a Bunsen burner.
well, well, they still look at the changing of the color of a flame. So in a Bunsen burner, you can also see when something comes into the flame, some metal, the color will change, and that's actually atomic absorption all about. So, uh,
Fantastic.
but the development through the years, of course, has mainly been focused on bringing down the detection limits. You can see the change of the flame, but when the amounts of metals are very low, you can't really see a color change, and you want to be on just that offspring where you can see a change or not, and that is all about detection limits and how low can I measure. Yeah, like we said, mercury, for instance. So bringing down the detection limits, what you need to do is controlling the instrument parameters. That has become very important to achieve. And as the flow through the analyzer is one of the main instrument parameters, controlling the flow has become increasingly important. Other more general analytical trends, you see it also in other markets, miniaturization, the footprint in the labs is very important. The
That's
more
key for a lot of industries, though, isn't it? It's lab costs have grown substantially.
Yeah. So if you can put more analyzers in, you can, or you need a smaller space. But another thing about miniaturization is point of care. Don't know if you're aware with the term, but point of
I'm not.
care,
Please tell me more.
yeah, it means that you want to measure at the point where the problem is. So, or the patient, or the mercury in the fish, you want to measure as close as you can get. So not in a lab, and you have to travel with the sample under your arm, 300 kilometers to a lab, but you want to measure it on spot, on point of care. So that
So this is
is
field-based. This is portable. This is
yes,
instruments that you can
yeah,
take with you rather than taking the sample.
correct.
Fantastic.
That are yeah becomes very important. But another term is analytical intelligence. You want the analyzer to be as smart as possible because you want to do all those measurements by maybe one person that controls the lab. Maybe you want to do it remotely from your home. We are working on that and see these trends. For instance, Bronkhorst flow controllers can already give an indication of the state of the instrument, of the health of that instrument. But we are also looking at how we can make predictions regarding predictive maintenance of the analyzer.
Yeah, and that's a trend that fits with the wider world. Of course, we see Internet 4.0 becoming more and more prevalent in daily life. It fits as well.
Correct. Yes.
So moving on to
cost is also a trend in the market, and it's always a drive to get the lowest costs into the components, because one analyzer it has a lot of components, and you want that analyzer to be as cost effective as possible, or the manufacturer wants the analyzer to be as low cost as possible.
Absolutely, yeah. Commercial aspects, of course, play a huge role in development of these things.
Yeah.
So what are the benefits? Talking about the commercial aspects and where Bronkhorst tie into this, what are the benefits of using a flow controller in this market, and why? And following on from that, what specific advantages do we bring to the instruments that we are a part of?
Yeah, to explain the use of a mass flow controller, I have to go into the technique of the analyzer in short.
Please do.
Yeah, don't want to make it too difficult to understand, but elements in the sample that you want to measure, they are separated from each other either by combustion or after ionization, so that you get the element in a form that can be transported by a carrier gas. So this carrier gas takes care of the transport of the separated sample components. And sometimes, in addition, reaction gases may be necessary for chemical and sometimes physical reactions to take place in order to distinguish between the elements to be measured. For instance, if you have a component that has the same mass, when you analyze it on a mass spectrometer, some components, like I mentioned silver, they have a specific mass, but silver together with, or maybe another metal together with another component has also the same mass as silver, and you might see that as silver, but it is not. So you want to remove that other component so that the mass becomes lower and it can be separated from each other. So that is why you sometimes use reaction gases and the flow controllers to deliver the carrier gas, to control the carrier gas, and to deliver or dose the reaction gas. They need to be very accurate, of course, especially in the case when you dose something to that reaction, but also need to be very reproducible. In other words, the results of the analysis should not only be good, but should also be exactly the same if you perform it again the next day or on the top of a mountain in Switzerland. So reproducibility is very important in this market. And to mention mass flow, if you measure mass flow, and you know that, James, when you measure the mass, it is not influenced by outside parameters like temperature or pressure. So the mass
and that's
flow.
why Bronkhorst chooses mass, because it indicates repeatability, which you indicated earlier was a very important parameter.
Correct. Yes. Another point in this analysis is cleanliness. You measure at very low detection levels. So these analyzers they involve very low concentrations of the elements that you want to measure, and therefore you do not want to have any contribution to the signal coming from the carrier gas or other wetted materials. So, and here comes Bronkhorst in play. We have a very big experience with accuracy, reproducibility, repeatability, as you said, and cleanliness. We have the best instruments, cleaning procedures available in the market. And recently we invested in a cleaning plant where we can clean all the material of our products to ASTM norms. So for this market,
sorry, Rob, I'm guessing that's a cleanliness standard that the
yes,
industry
that's a
uses.
cleanliness standard used in the industry and also recognized by customers of ours. So that's why we invested very bigly in that. So, and besides that, we instruct our suppliers how to clean the products that they deliver to us. And working already with mass spec customers, that has given us a lot of insight through the years in contamination and how to solve this.
Fantastic. That was, I didn't want to interrupt because you were on such a good flow. So thanks for that, Rob. I really appreciate the thought into there. So how do we, Bronkhorst, fit into this process, and how do or can Bronkhorst help?
Yeah, we already gave a lot of information, of course.
We did, yeah. If there's anything else in there, then please feel free.
And if anyone has a question that comes up from us speaking to each other now, they can always bring that on later, of course. But how do we fit in the process? Is we work, of course, with customers, manufacturers of analytical equipment, and they often have very different wishes when it comes to the use of flow meters and flow controllers. So the form of that flow meter is very important, of course. That this flow meter needs to fit in there, a very compact analyzer. And in addition, the system architect also looks at signal processing, control and power supply, things like this. Very important things to build your analyzer. So all this determines the choice of an instrument, and not unimportantly, there's often also a cost aspect, as we already said, to it.
So there's a flexibility where we need to take on board the needs, wishes of the customer, form, fit, function, communication, and cost requirements. Yeah. So we're not talking about off-the-shelf solutions here, are we?
No, you cannot just get the price list and then pick an instrument from that. There's much more to it. What the normal thing to do is that our engineers, who are very specialized in engineering customized flow solutions, they team together with the engineers of the customer to form that team and speak about the wishes, the PNID, and to look at what is important for that analyzer. And in that way, we can achieve very good results in looking at all the aspects of engineering, testing the prototype. So that is a little bit how it's done these days.
Fantastic. That's brilliant. Rob, thanks for joining us today. It's been a pleasure to have you here. If you like the podcast, share it with your colleagues, and do not hesitate to contact me or Rob on LinkedIn. That's James Walton and Rob ten Haft. If you have any questions or want to know more, make sure to follow our Bronkhorst page on LinkedIn to stay updated with all the trends and news. Finally, stay tuned and join us on our second podcast, where we'll be going to talk about how we can help you realize solutions that meet your specific requirements in any application.